Okay, hopefully this is okay for audio level. Let's test that. Okay, hopefully this is okay. Alright, testing again, and I'll just pause the music. Alright, testing again, and I'll just pause the music. Okay, the music can actually be louder. Alright, testing again, and I'll just pause the music. Alright, this should be good. So, today, I have this in front of me, and I need a caliper, so I'll be back. Alright, so today I have a bit of a challenge. And I'm back, by the way. This is a Cisco Linksys 10100 16-port workgroup switch. We have a no part number, but that's all the data on the bottom. If you want to read it, once the camera focuses. Focus! Focus! I think I focus off, but either way. It's just a... Oh, model number. EZX S16W. Echo Zulu X-Ray. Sierra 16W. Has a model number on it. And that's all I know. And a little switch. There's MDI or MDIX. And 16 ports on the back, as you can see. So, what we're going to do is we're going to try and design either a mount bracket that just goes over these and goes down and hold it in 4 places, or a bracket that doesn't go right across but holds it here. I'm thinking the 4 places bracket is going to be better because this is straight down and we don't have this trying to, like, it won't be pulling as much, and I won't have to do as much design work that way, because I'm also not going to be able to, like here, I'm not going to be able to print this overhang here, this direction, so I'm going to have to print it as if it were sitting like this, right? So that it would be printed sideways, as if the thing was here, and I'm going to be printing 4. So I'm going to try and just make it so that it fits flush in here and holds down on just probably the back too. Did that literally just come apart? Yeah, it did. Huh. What is supposed to be holding this together? Literally nothing. Alright. Okay, whatever, it doesn't matter. Does not affect the building of the thing at all, because it will be clamping these together. So, we're gonna start with that. So we're gonna start with a metric part on Solid Edge. There we go, start with a new isometric part. The first thing we're going to do is we're going to design our bottom plate. So it'll be a rectangle with a hole in it for the screw that'll hold this up. So we're going to do that on the upright dimension. We'll design it as if it's sitting like this, and I'll rotate it later in the software to print it. And I'll be printing it on like the best print I can get out of that printer. So the first thing we're going to do is we're going to want to do a square, and we're going to want to lock to plane. So let's rotate this. Let's lock to that plane. So we'll hit F3 to lock to that plane. And then we'll just make a square. And we're gonna make it even, so we're gonna make it, start the caliper up. Wish I had a way of reading the digital output on these. There is a way, but, so let's make it, here, let's do it this way. Let's make it a total of 24.98 millimeters. So let's make it 20. Let's see what that looks like. No. Yeah, 20 looks right. So we'll make it 20. I'm gonna back that off because that looks like it'll be really loud for anybody watching. So we'll make it 20. So 20 by 17. Actually, no, let's do the inside. Inside of it so we don't have to taper it. 20 by 16.83, so 20 by 16. Okay. There we go. And now, let's go on top. So now, obviously, we're going to need two pieces. We're going to need the extruded part here, and then we're going to need a, let's go with, what? Thickness of 3 mil to go up, starting at 3 mil at the bottom, and then we'll taper it down to like 2 at the top, just for looks and aesthetics. Or do we want to do it this way? That might work. Actually, I got a better idea. Okay, so we're going to tip it on its side here. And what we're going to do is we're actually going to extend this entire thing up full height, then we're going to cut it off at the top, between the top and the bottom. So what we'll do is extend it up full height, which is... Oh, actually, I need to do the height of the thing. .58, so 59. That's 58.94, so 59. So we're gonna extend this entire thing. Usually I don't do this, like start extruding right away, but... Oh wait, I want to select. So let's... 59. So that'll be a whole box, and then now we're gonna look at the front, I think. Yeah, we're gonna look at the front. And then so, we want it at the top, we want it to just be a little square at the top. So I'm gonna design that square right now. Out of lines, and I'm gonna just do a 2 mil by 2 mil square. Or, sorry, 3 mil by 3 mil square, and that'll be because the height of this little part in here is 3 mil. So the height of this little inlet at the beginning is 3 point something. Yeah, pretty much 3. So I'm gonna just do a 3 mil by 3 mil square at the top. Let's... Okay. 3 mil. So make that 3. Lock that at 3, and then we'll lock it to here. And then we're going to do another 3. Lock that at 3. And at 90. Then we'll just go straight back, which will be another 3 mil. All the way back. So, what I'm going to do is I'm going to take from this corner here to this corner down here. I'm going to cut off this chunk that's on the side here. So we're gonna select that afterwards, because I gotta put the screw hole in. So let's go to the top and we'll put that screw hole in right now. I'm gonna put the screw hole dead in the center of this for maximum strength. So the screw hole, so we're gonna do 2 circles, and then we're gonna unlock from that plane, and we're gonna lock to this plane. We're gonna go dead in the center, and we're gonna do 2 circles. I need a screw though, so I'll be back. I'm gonna get a screw that I like. Oh wait, I have a box of screws right behind me. Sweet. Alright, so I'm gonna use one of these screws.
Face to face, I found my pain beneath the light.
So we need one that's not long as this thing, because it'll be countersunk in. But we do need a decently long one, and we do need 2 of them. So I need to find 2 of the same type of screw, which is easier said than done. Okay, they're not the exact same, but they're close. See if I can find a different one. It's closer. These would work full depth. So say if they sunk into the wood about that much, these would work. I have 2 of these. They're Robertson, so I like it. Okay, so these will be our screws. These screws are bottom of head to end 63-ish. I believe they're both the exact same. Yeah, they are. So we'll use both. We'll use these 2 screws. So as is. Wait. Well, they're slightly different heights, but they're good enough. So as is, they would work just by tightening them down exactly there, but getting them exactly in the spot, it's going to be difficult. But our inside size, so it needs to be 4.1. So we're going to do 4. Can I get away with 4.5 inside? Actually, I can get away with 5. And there'll be a lot of slop. So we'll do 4.5. 1, 2, 3, 4, 5, 6, 7. So that, yeah, that'll be good. So we're gonna do 4.5 inner diameter. Oh, shit. So I'll do 4.5. So 4.5 inner diameter. Oh wait, no, we need another one too. So the reason we're doing these 2 circles now is so we can extrude them later. And then they'll be in the center, and we don't have to extrude from the bottom. So we'll do, since it's 4.5, we'll do 7.5. Let's see, what's 7.5 look like? It's quite large. How big is the head on these? 8. So it's not as big as the head, so we do have to go farther. So we'll have to do, let's do, because it's 8, so let's do 8.5 to make it big enough for the head. So diameter of 8. Wait, 8.5. 8.5. So let's make that bigger. So this will be the hole that needs to go right through, and this will be the hole that needs to go down to the head level. So if we want to, like, say if we want to sink it into the wood about a ½ inch, head level will need to be, actually, look at it this way. I have a hole in my desk, so let's sink it into the desk to the height we want it to. Do I have my drill charged? Where's my drill? Yes, I do. So, let's... Does it... Is it the size? Yeah, good enough. It's there. So... Okay, so head depth from the top of this, so we need to actually do here, approximately 14. So we'll do 15. So let's remember that. Let's cut the side. and we'll remember that dimension. So here, and let's subtract everything, get rid of it, and then let's extend this 59. How big is this? So if we extend this, $59. Fine, alright. Oh, okay, cool. 15. So that should work. And then we'll just extend this part. I'll draw a line here and we'll extend that out. Only issue is, what do we do with this? So it selected that. Alright, so let's do an extrude. And we're going to select single. So, and then we'll just cut a hole right through. Oh crap. Extrude, single, cut. There we go. Now, if we go to the top, you should be able to see right through. Sweet. Alright, so now, that did it perfectly. I didn't expect it to, but it did. Sweet. So we're going to do that, and then we're going to do this line, and we're going to select, and we're going to just draw a line straight down that's 16 across. And we're going to select that face, and we're going to extrude it out. And that'll be from there, so we're going to extrude it out all the way to the inside of this. 24.61. So we're going to do it 24.5 to allow for printer error. So we're going to extend it 24.5, and the radius of this, or well, yeah, radius of this would then be the inner depth, which would be 16, so it would be 8. So then let's round these corners off by 8. So, oh wait, I do need it. No, I need this corner actually. So let's round these corners off, both of them, by 8. And then so that makes an 8mm round, with hopefully that inside being the inner, yeah. So it's 4.48. So let's do 4.4. And we actually need to extrude this. This is 3, so we need to extrude it 1.4 outwards. 1.4. So, outwards. And then, okay. Let's get rid of these rounds. Let's just, oh, crap. Okay, so we'll round it after. So we need 1.4 extruded outwards. By 1.4, 1.4. So we'll cut it and then we'll round it. So to cut it, we're just gonna do, on this plane, we're gonna do a line from this corner to the top of that, which is our old size. Then we're gonna zoom in and select this face, and we're gonna take it down, cut everything off to making that the tapered part, and then now we'll round the corners. So the round should still be at 8. Yeah, so 8, 8. And then that should be the exact design that we need. Sweet. So we're gonna save this. Network switch mount. Then let's see what we can get going here. So let's get it uploaded to Thingiverse. Oh, that's cool. Airplane. Let's sign in. Why do I have 63 notifications? Ah.
Drink, think deeply as I sing. Finally, someplace I found peace in the dark of night. Tabletops counting hours in the early hours. Stone cold inside. Banging drop stanzas, never needing answers. We wander all alone, but we can't find the street lights go. We wander all alone, but we can't deny we are the street light people.
Okay, so
Pills, thrills, chasing whatever kills. For so long, I forgot how it feels. In the
we're gonna make a new thing.
tabletops counting hours in the early hours. Stone cold inside. Banging drop stanzas, never needing answers. We wander all alone, but we can't find the street lights go. We wander all alone, but we can't deny we're the street light people.
Alright, so we're gonna upload this thing to Thingiverse. Upload a thing. First of all, we gotta save it with the... I also might upload this. Barely focuses, hold on. So, I might upload this. So this is a mount for a keyboard. Or not a mount, like a stand, like one of the little kickstands. For a Razer or not a keyboard. I was commissioned, kind of, to make this for my friend who smashed on his keyboard so hard he broke one of the mounts off. Fit like a glove, like it was meant to be there, and I believe it is stronger than the real thing. I don't have a real one to show you other than the one on the bottom of my keyboard. But you see even these ones have that cutout in the center. I neglected to put that cutout in because I figured, why? It's not as strong when there's not as much plastic there. So why put the cutout in? It doesn't matter. So I didn't. And I believe, like, there hasn't been a conclusive test of him slamming his hand down on his keyboard because he didn't want to break it again. Of this. But design, I'm gonna go with 100% except for the cut. The little cut. Other than that, 100% accurate to the real thing. Other than that cut and a few creative changes that made it actually look a lot nicer. Like, on this one, there's a hard cut-off edge. On mine, I decided to taper it to even out the force a little bit, so it's got a little bit of a taper to it there on that end. It kind of tapers down. But I like it. It worked out. It worked out real good. That's just a test print, so it's useless to me. Same thing with this. This was a print I found on Thingiverse. It is, or well, was a mount for an HTC Vive controller. Same friend who broke his keyboard decided one day to, like, pull on it while it was mounted on the wall like that. And he decided, pull on it and see what happens. Snap. Of course, I wasn't the happiest, and I had to print another one, but I tried to glue that one back on, and as you can see, that kind of failed, so I shot it with a BB gun. I was bored. Anyways, I am now going to upload this thing. I'm going to save it as an STL first, because you can't upload it without being an STL. Network switch mount for Linksys. I also got a new network switch today. Walmart on sale, 25 bucks. If I can pick the damn box up. This one. The Linksys. Where's the model number? SE3008CA. So that makes me think there's a US version as well. Because that CA means Canada. Usually. So, anyways, don't push on these feet. They actually go inside of the router or switch. So, don't push on the feet any farther than they should go, because they will drop inside the damn thing, and that's kind of dumb. It's kind of a shitty design. Anyways, so let's move this over and let's get to Linksys. This is a ESX S ESX or EZXS 16W. And we're not going to save this as a .par. We're going to save it as a, not a .sat, and .stl. So we're going to save that. Into my documents. So we're gonna upload that. thing name. I guess we'll go on other. I mean, there's no real category for. Oh, there's toy holders in boxes, or tool holders in boxes. I guess it'll go under DIY because it's kind of a DIY thing. Sure. Okay. So that should be good. For anyone who's getting it, it's their problem to find a screw that fits that. I don't know what my printer's gonna do. I think it'll put support material here, which I'm fine with. Because I obviously cannot print it upright because of that big overhang. That'll be a lot of support material and it wouldn't build it right. So I do need to print it sideways. I don't know what it's going to do inside that hole. That might be an issue. Well, it's saved as an STL now. I'm going to save it on Thingiverse. Anyways, so we're gonna bring up Repetier host, which is what I use to slice my stuff. So start G, files. So I'll keep these screws off to the side here till this is done printing. We're gonna keep... Okay, so... We're gonna add... I'm just gonna see how it's gonna do this. So it's this one. Lay flat. Oh wait, now here's the rotate. Lay flat, lay flat, lay flat. Damn it. 90. So what we'll do is I'll move this up to the front. And then let's print that, or not print this, but slice this. I've told them peeling a bed, slow, very high quality support. So slice with slicer. So the one thing I'm worried about is that overhang. So what's it gonna do? It is gonna do a support layer. So it is going to do support material right up to the bottom of the center of that, but it is not going to do it inside, which I'm happy about. It also seems pretty confident on doing that circle. And how are we for layers? What are we going to do? Show single layer. So it's going to start out at 0, and then it's going to do... So it's going to do a bottom layer and then a support layer and then all the way up.
Staying up when I go out, you gotta know I'm all yours. But when I say what's that about, you start slurring.
Then it's gonna curve back in.
Tell me why you have to seem so distant when I'm holding you. Your fingertips are drifting away, and I fucking love how it hurts. Why do I, baby, why do I love the way you always leave me? Why do I, baby, why do I love the touch but never love the feeling? Why do I, baby, why do I love the way you always leave me? Why do I, baby,
So, okay.
why do I love the
So it
touch
starts
but never love the
with one little, like,
Why do
blip,
I,
and then it goes bigger,
why do I, baby, why do I
and it does a full solid layer as it goes around. Then as it comes back together, it does full solid layer around that. I wish it did full solid layer around. That should be fine. Okay, cool. We're gonna get to printing this, and I will upload pictures once it is done. I'm sorry, but I'm not going to show you the print. That would take way too long. So yeah. I will see you in the next one. Have a good day. Gotta find my stop streaming button. There it is.